Alright, so these are your examples for elevation and depression. You should have already watched the video with the pretty princess and the dragon and the really strong man. Okay, so what I need you to do, somewhere at the top, make a little Z, and hopefully that's a little easier for you to draw than me. The top and the bottom of your Z are supposed to be parallel. And just put a little D right here for depression and E right here for elevation. Now remember, those two are going to be congruent, so put your little congruent bunny marks. Okay. The other thing I need you to write down, your SOHCAHTOA phrase. So go ahead and write that at the top somewhere, wherever you have room. And then there's one more thing that I need you to write down. Whenever we're finding the angle, we have to use inverse. Alright, so put inverse. And put your little -1. And then put angle. Okay, so those are the 3 different things that I need you to write down at the top somewhere so that you remember. Alright, so let's go ahead and do our first example. For our first example, it says we have a man flying a kite with 100 foot of string. The angle of elevation with the string is 52 degrees. How high off the ground is the kite? So for this one, they gave us a picture, which is really nice. All right, so let's just start from our 90 and label our hypotenuse. What's our hypotenuse? Good. 100. All right, because it's across from our 90. All right, and then we're going to use our angle to label everything else. So very far away is your opposite. And then right next door is your adjacent. Now, do I have anything for the adjacent? No. So I'm not going to use the adjacent. I'm going to use whichever one has O and H. So which one has O and H? Yep, sine. Okay, so sine of your angle, sine of 52. And since it's SO, S-O-H, we know that the opposite is going to go on top of your fraction. And 100 goes to the bottom. Alright, now I need to move that 100 away from my x. So how am I going to move it right now if it's dividing with my x? Yep, I'm going to multiply. So if I multiply this side by 100, then I also need to multiply the other side by 100. Okay, can't have anyone getting jealous. Alright, so in our calculator, we're going to plug 100 sine 52. So pull up your calculator. The first thing, though, we need to make sure it is in degree mode. So click Home, Settings, Document Settings, and it is in degree. You can just click on it to make sure and then hit Make Default if you want. And then go back. And so we're doing 100, hit Trig for sine, and it was 52. So we'll say this one is 78.8. So if you didn't get 78.8, please let me know. .8 feet. Okay. All right. Number 2. From the top of a vertical cliff, 40 meters high, the angle of depression with an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? Okay, so first off, they didn't give us a picture, so we need to make our own picture. So let's make a cliff. It's a nice cliff. Okay, how tall is your cliff? 40 meters. So we'll put our 40 in there. Alright, so we have an object on the ground. Let's just put the object over here. Okay. Alright, so obviously you know we're going to need a triangle. So let's just go ahead and make one. So straight. Oh, well, that's kind of straight. Yours hopefully is more straighter than mine. Alright, so my object is in the wrong spot, so I'm going to fix that real quick because That looks silly. Okay, there we go. Alright, better. Okay, so how far is the object from the base of the cliff? Okay, so here's the base of the cliff, the bottom of the cliff, and it wants to know how far the object away. So my x is going to be this distance right here. So okay, put your x. Okay, now this 34 degrees is our angle of depression. Alright, so what you're going to do, pretty princess is looking straight out, and the 34 degrees is going to be right here. Okay, now, remember your z? That's going to come into play. You have two different options for how you're going to solve this. You can either make your z and realize that your 34 is going to jump straight in to this triangle right here, because we know that they are congruent because the top and the bottom are parallel. Or this right here is making a right angle, and we know that right angles measure 90 degrees. So if you wanted to, you could just do 90 minus 34 and find this one. Okay? Doesn't really matter which way you set it up. Okay, so from this 34, I'm going to use this one down here. 40 is very, very, very far away. So 40 is my opposite. Good. And right next door is my adjacent. And this one that I don't care about is my hypotenuse. Alright, so since we're using opposite and adjacent, we need, yep, tangent. Okay, so tan of your angle, tan of 34. And opposite comes on top, so it's going to be 40 over x. Alright, now, remember when your variable's at the bottom, we have a little bit of a problem. We're going to just switch our spots. So the x and the tan of 34 are going to switch spots. So we get x equals 40 divided by tan 34. Alright, so we're going to plug this into our calculator. 40 divided by tan of 34. So 40 divided by tan 4, 59.3. So again, if you didn't get 59.3, let me know. And we'll put our units on their meters, make it legit. Okay. Example 3. We have an airplane taking off at 200 yards in front of a 60-foot building. At what angle of elevation must the plane take off in order to avoid crashing into the building? Assume that the airplane flies in a straight line and that the angle of elevation remains constant until the plane flies over the building. Until it literally flies over the plane. What are you saying? Okay. So the first thing I need you to notice is that how far away right now is the plane from the building? 200 yards. How tall is the building? 60 feet. Are feet and yards the same thing? No. Okay, so what we're going to need to do is we're going to need to convert one of them to the other. Alright, so I know that there are 3 feet in a yard. So I'm going to convert the 60. You could convert the 200 if you wanted to. So right now the 60 is in feet, right? Alright, and you'll do more with unit conversion. Like you do a lot of it in chemistry, for example. That's kind of far away. Alright, so I have 1 foot, and I'm going to put the foot down here because I want my feet to cancel out. So if I have feet at the top and feet at the bottom, they're going to cancel out. Okay? And we said that there were 3 yards in 1 foot. Okay? So my feet and my feet are going to cancel out. And I'm going to do 60 times 3. Alright, hold on a second. Obviously, it's way too early to be making these videos because I just made a really silly mistake. Okay? Um, so, I just said that there were 3 feet in 1 yard. And where did I put my 3? I put it with my yards and not my feet. Okay, so let's fix that. So there are 3 feet in 1 yard. Okay, now we're right. Alright, so we're not going to multiply 60 times 3, we're going to actually divide it. Sorry about that. Alright, 60 divided by 3, we get 20. Okay, now instead of using 60, we're going to use 20. Okay? Now the other thing that you should be noticing about this one is we are missing the angle. So we're going to end up using the inverse. Okay, so first we got to figure out which trig ratio. So the 60 that's now 20, we're going to use 20, is really, really far away. So opposite, and 200 is really close. Adjacent. So opposite and adjacent means we're going to use tan. So 20, ooh, that's supposed to be 20. I'm not sure what's going on with that. So 20 over 200. Okay, so let's go ahead and plug that into our calculator. So this time you don't want the regular one, you want the inverse. And we're doing 20 over 200. So about 5.7 degrees. I know we usually round our angles to a whole number, but because this worksheet said 1 decimal place to the nearest tenth, we'll do 5.7 degrees. Right? Alright, so example 4, we have a 14-foot ladder is used to scale a 13-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? Alright, so we don't have a picture, so let's make one. First, make your wall. Okay, and then we need a ladder. It's a nice looking ladder. And then we can make some grass down here if you want. Okay, so how long is the ladder? 14 feet. And how high is the wall? 13 feet. And we are looking for the angle of elevation, so with the ground looking up, here's my x. Let's label our picture. 14 is my what, since it's across from my 90. Yep, hypotenuse. And 13 is very, 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 very far away. So it is opposite. Okay. So, which one uses the opposite and hypotenuse? Yep, sine, but we are going to use the inverse. And which one goes on top? Yep, opposite. So 13 over 14. Your calculator actually wouldn't let you do it the other way because then you'd be saying the hypotenuse is 13 and one of your sides is 14 and the hypotenuse has to be the biggest. Okay. Alright, 68.2. Beautiful. Alright, number 5. Alright, so we have a person standing in a window of a building, and his eyes are 12.6 meters above the ground. There's an object 58.5 meters away. On a line directly beneath the person. Compute the angle of depression of the person's line of sight to the object on the ground. Okay, so make your building. Make a person. He's happy. Okay, he is 12.6 meters. And there's an object. Let's say it's a beautiful lady. Oh yeah, she's got some nice little hair going on. She might need to get one of those sides trimmed. Anyway, so on a line directly beneath the person to the object is 58.5. 58.5. Alright, so let's turn this into a triangle. Alright, so we want angle of depression, which we know is straight out. And it's going to be this angle right here. But we know, because of our z, which is backwards, that that angle and this angle right here are congruent. So I'm going to use the one inside the triangle. Alright, so let's label it. We don't have the hypotenuse, but we do have the next door, which is, yep, adjacent, and that, which is opposite, and which uses the adjacent and the opposite. Yep, tan, but we're going to use our inverse, so tan is 12.6 over 58.5. And let's plug that in. Alright, so about 12.2. Oh, wrong page. 12.2. Alright. For 6, you're actually going to do that one on your own. Okay, so let's just switch it real quick and read it. We have a ramp that is allowing vehicles to climb the 2-foot wall. The angle of elevation must be 30 degrees or less. The longest available ramp that we have is 5 feet. Can this ramp be used safely? So what you need to do, label your triangle, and figure out which trig ratio you're going to use. We know that we have to use inverse because we're finding the angle. Once you do your trig ratio, if you get something less than 30, the answer is yes, it can be used safely. If you get something like 52, then no, the ramp cannot be used safely. Alright, so go ahead and go.